In our lesson with logarithmic equations, here I'm going to go through another way of solving these logarithmic equations with a word problem. So it says the loudness of a sound L in decibels is defined by L equaling 10 times log base 10 of R, where R is the relative intensity of the sound. A choir director wants to determine how many members could sing while maintaining a safe level of sound, about 80 decibels. If one person has a relative intensity of 10 to the sixth when singing, then how many people could sing with the same relative intensity to achieve a loudness of 80 decibels? Now, in the lesson video that I made earlier, I showed one way, and I was exponentiating both sides. This one, I'm going to show you how to use the properties of logarithms to solve. So the first thing I'm going to do is write my variable or my equation down, but instead of L, it says L is representing the loudness of sound in decibels. They're telling me to use 80 decibels. So I'm going to have 80 equals, and then I have 10 times log base 10 of R, and R is the relative intensity. And if one person has 10 to the sixth, I need to find how many people can be in the choir to reach the 80 decibels. So that's going to be 10 to the sixth times X. Now to rewrite this, I'm going to get the log by itself. So I'm going to divide by 10 on both sides. And then I'm just going to switch the sides around so it makes it a little bit easier to read. So now, right now, I have log base 10 of 10 to the sixth times X equals, and then 80 divided by 10 is 8. Now with our rules of logarithms, since I have a multiplication problem here, I can expand that to make that an addition problem. So I would actually have log base 10 of 10 to the sixth plus log base 10 of X, and this is going to equal 8. Now we had learned in a previous lesson that the base of the logarithm is the same as the base of the exponential. They undo each other, but we also know that if I put this exponent out in front, this is the power rule of the power product of a logarithm. I put the 6 out in front, and now I have 6 times log base 10 of 10. Log base 10 of 10 is 1. Because if they are inverses of each other, the inverse is always going to equal 1. So I have 6 times 1 plus, now I have log base 10 of X equaling 8. Now I want to get this log base 10 of X by itself. So to do that, I'm going to subtract 6 on both sides. And now I'm left with, I'm going to put this over here. So now I have log base 10 of X equaling 8 minus 6 is 2. And now I can rewrite this as an exponential. So 10 to the second power is equal to my X. That means X is going to equal 100. So there can be 100 members of the choir to reach a loudness of 80 decibels. The second equation, or the second problem, is the acidity of a substance can be measured using the pH scale, which is actually a measurement of the concentration of hydrogen ions, or H+, in moles. The formula is pH equaling log base 10 of 1 over H+. How much hydrogen is in a liter of acid rain, which a pH of 5.2. So I'm going to rewrite this, and I'm going to expand this part, because when I'm dividing with logarithms, the rule says I can rewrite that or expand it as a subtraction problem. So I'm going to have log base 10 of 1 minus log base 10 of h positive, and that's going to equal my pH value, and they said the pH value is 5.2. Okay, now I can rewrite this log base 10 of 1, which really means what do I raise 10 to what power gives me an answer of 1. Well, I know that anything raised to the 0 power is 1, so log base 10 of 1 is 0. And then I have minus log base 10 of h positive equals 5.2. Now I want to get this log by itself. And to be honest, I don't need the 0 here, so I'm just going to cross that off. To get this log by itself, I'm going to divide by -1. And now I have log base 10 of h positive equals a -5.2. And to solve this now, I can write this as an exponential, so 10 raised to the -5/2 power, or -5.2, is equal to h positive. Now if I take my calculator, and I would just do 10 raised to the -5.2, and I get 6.309573445e to the -6. They're asking me to put the answer in scientific notation. So h positive, and we're going to round it to 1 decimal place. So if I go to my calculator again, it would be 6.3. So this would be 6.3 times 10 to the -6th power, which means it's a really, really small number. But that's how you can solve this word problem using the properties of logarithms.